At Google DeepMind, we have a bold mission to advance science and to benefit humanity through advancement of AI. And so that's something that we take very seriously. We build models like Gemma, Gemini, Veo, AlphaFold, and many more to try to achieve that mission. On-device intelligence is an important frontier for everybody because making AI personal, private, on your device, low latency, and many other things, they're really in the hands of developers. And so the key for on-device models is that everybody has a stake in a lot of these things. You could use Gemma 3N or Nano to build something new and amazing in AI today. And so I think it's going to completely revolutionize the future of what's possible with AI. On-device environments for AI are naturally more private area, right? Because we're not sending information to server-side models or other services, it more naturally protects your personal information on device. However, we take privacy and security very seriously in all of the models that we build. So I don't actually think that there's as much of a delta between on-device models and server-side models for privacy and security as people sometimes think, because it's really important that we hold ourselves and the entire industry accountable to make sure that we're handling data appropriately. And that's a responsibility we take extremely seriously at DeepMind. Matformers are an amazing innovation. You might have heard of this technique called sparsity, where essentially you load the entire model into memory, and then you only run some experts, a mixture of experts. You only run some of the parts of the model in order to achieve a task. So that might be, I would load the entire model in memory. It takes a whole lot of memory and server, but for each request, I can use significantly less compute, et cetera, to achieve similar quality of a larger model. In Gemma 3N and Gemini Nano 3, we've almost inverted that with Matformers. And the idea is very simple. How is it that we actually only load the parts of the model into memory that matter? So we use less memory as opposed to using more memory. And this is really custom built and really important for on-device use cases. Because if I take all of the RAM on your phone, then your phone's not very useful anymore. And so if we have the same power of a model, but with much lower RAM footprint and a lower compute footprint, then that could unlock completely new capabilities for everybody that has a phone, which I assume is almost everyone that uses AI.